Problem 45 of Neetcode 150, reverse node in K group. So let's go ahead and read the problem. You are given the head of a singly linked list head and a positive integer k. We have to reverse the first k nodes in the linked list, all right? And then we have to reverse the next k nodes and so on, all right? They are telling us that if there are fewer than k nodes left, we have to leave the node as they are. Okay, so let's see an example here. Um, we have a linked list composed of 1, 2, 3, 4, 5, and 6, and our k value given is 3. So you can see that in the example, they took the first three elements, so 1, 2, and 3, and they basically reversed it. So now you can see you have 3, 2, and 1, and then you have to take the next three elements, so 4, 5, and 6, and you have to reverse them. And if you have a 7, you will have to reverse also that 7 here. So it will become 3, 2, 1, 7, 6, 5, and 4, okay? The only exception is if we stop at 5, we will just have let the linked list be 3, 2, 1, 6, and 5. All right. With that being said, let's see how we can proceed to solve this problem. So let's say we have our one. Oh, I'll erase that. Okay. So let's say we have one linked to 2, linked to 3, to 4, to 5, and let's get that 6 here. Okay. All right. So we have 1, 2, 6. Okay. Um, First, we want to create an element here that will be linked to uh, the first node. So um, I would like to call this, let's say, the linked list, or let's call this the starting block. All right. So we have to let's set in our example as the k value is 3, right? So basically I took the exact same example of that Neetcode is giving. um, so we are gonna have um, to have a pointer to the third value. So let's start a pointer here, right, at the list the list block, okay, or the starting block. So then we can move 3 times. All right, and then we can actually access the what I will call the right uh, the right list, and now that we have the left list, the left list. And actually, when we are at this point, we are in a good position where we can actually start reversing this list into a 3, 2, 2, 2, 1. If we reverse that, we are also gonna have our, let's just call this P for the, or SB for the starting block. All right. Okay, so let's call this SB. So SB is still going to be connected to 1 after we reverse this. So if we use the basic algorithm to reverse a linked list, we are going to have 2 pointing to 1. Oh, I have problems with my mouse tonight. We're going to have 3 pointing to 2. And we can actually make sure that 1 is pointing to the this element, or that the next element once we reach the third element. All right, so we are gonna get that, and 1 is gonna be connected to 4, 5, and 6. So we just have to ensure that we keep we have to keep this value somehow in register, because it is important to then reverse the rest of the list. But after this, we have to make sure that our SB is actually pointing back to what will then be the first element All right, so it's gonna have to point here, and then we can go ahead, um, and from this um, right side of the list, we can actually go ahead and reverse the link. Okay. Oh, it's not super. My drawing skills are not quite impressive, but I think you understood the concept. Let's go ahead and try to code this. So um, the first thing that we're gonna want it's what I call uh, the starting block, right? And the starting block is basically gonna be equal to the list node. Let's give him the default value of 0, and let's make sure that it points to the head of the list, right? So then we can render starting block that next, so we can have access to the new um, linked list, and then we are we are gonna say that the left list is gonna be equal to that starting block. Okay. And then we can do a while loop. So I will do a while through and just had an if statement inside and break whenever um, we we reach a value that is no longer in the linked list. Because remember what we did at first, we had a sort of uh, we had a runner that ran through the number 3 here. Um, but once we reverse that list, or that left side of the list, we actually want to reverse the right side. So we have to make sure that we still have a runner that starts at 1 and that keeps running through the element 6, because the element 6 is it will eventually be the first element of that right list, right? So uh, if after every modifications, we right, so if after every modifications, let's say we are done with all the reversals and we have 3 2 1 6 5 and 4, um, at this point our runner will be there, and if he keeps running and he reach basically an empty space, so let's just write x. If he reaches an empty space, um, then we reach the point where we know that we actually reverse everything we had to reverse. So um, we are gonna call this right the runner, and the runner is going to be equal to a value. But to get this value, let me actually get another write another functions that we're going to call actually let's call this the run. Okay. So what this value is basically gonna take, well, it's gonna take the current value, so let's call this here, and it's gonna take the k, right? So from the current value, where up to where's our runner gonna end up? So this is the function. So we are basically gonna have to move the pointer of the current by k positions. So we are gonna say, well, there is a current, right? Because we might gonna end up having a current pointing to none. So what we're gonna say is while there is a current, and also while k is smaller than 0, because we are gonna decrement it every time until it reaches 0. So that's how we are gonna um, move our current. So current dot next, right? So every time we move it by 1, and we are gonna decrement it by 1. Okay, so after we return the current. Okay, so this is how the runner is gonna move forward. Um, So we are gonna say that the runner is equal to that function run, and inside we are gonna give the left list. Um, so left list, because we initially start there, and or also the k value that we are given. Okay, and then we are gonna say that if there is no runner, so if not runner, well, it tells us that we ran out of bounds, and we can actually successfully break the while loop. Okay, so after this, we are gonna set our right list, and our right list is basically going to be equal to the runner dot next, right? Because we want the value after the kth element. So um, the right list is going to be this. Great. After this, we are gonna do our the reversal of our linked list, and to do so, we need a previous value, and we need the current value. Um, Initially, the previous value is basically going to be the first element of the right list. Okay, if you remember my example, we add 1, 2, 3, 4, 5, 6, and initially after the first reversal, um, we had 3, 2, 1, 4, 5, and 6, right? So the one which used to be the first value is now pointing to the runner that next. Okay, so initially we are going to set the previous value to runner dot next, and we are going to set our left list. So our left list um, our left list, sorry, that next, because the current is the first value of that left list. So after this, we are gonna say that we want to run this until the current well, while the current is not equal to the right list element. Okay, this is our condition. um, and what we want to do inside this, well, we want to first hold, because when you change the pointer, you have to keep track of the previous one. For example, here we are going to hold the current value dot next, right? Because after this, current dot next is going to be equal to the previous value, so that the current is pointing to the previous value. That's how you reverse a linked list. So curve of next is going to be equal to previous, and then you can say that the previous is equal to what the current used to be, and the current is equal to that the value that you hold, which is the what used to be the current next, so the value to the right of current. Okay, and once this breaks, we are gonna have actually 3, 2, 1, 4, 5, 6. But notice that the the starting block is still pointing at 1. So what we are gonna do is that we are gonna hold the left list. We are gonna hold the left list up next. So this value, and we are gonna set the left list. Sorry, I have a hard time pronouncing that word. So left list that next. This is gonna be equal to the runner. Okay, so that the runner that used to be basically 3 in our example, where we add 1, 2, 3, 4, 5, 4, 5, 6. So the left list dot next is now going to be equal to that runner, and we are going to set that left list equal to that hold. Okay, so this is how we are going to get a starting block pointing to the 3, and a 3 pointing to a 2, and a 2 pointing to a 1, and now the 1 is pointing to the 4. right? So after this, um, we are gonna go again on the while loop. So we are gonna reverse what used to be the right side, and after this, once the right side um, is also reversed, we are gonna set um, well, we are gonna move our runner again, but we'll see that we reach a none, so we are gonna break, and after this break, we return the starting block dot next. Okay, um, I think that's it. So let's go ahead and submit this. Hopefully, it's gonna work. We got an error. So while cure, okay, line 32. Let's solve this. Okay, I forgot it. And all right, let's see if that works. And there you go. So we got it. All right. So basically, that problem is basically just the reverse a linked list problem, but we have to do this twice, and we do this with having a left list, a right list, and a runner, and that's it. So I hope you learned from this video, and I hope to see you in the next one.